Hey guys, all right, just give you a heads up. My kids are like super amped upstairs. So if you hear craziness, it's them. That's all I got. Hope you're doing great. Let's jump right into it. So, last time you guys did some rounding with some numbers that did not terminate, that went on forever, and then did some calculations with it, whether it was adding, subtracting, dividing, or both. Today we're going to do something similar, but just a little bit different. So typically you get a lesson summary at the end of the lesson. I'm kind of bringing this at the front because I think it's important. So one is just reading this to you. It is not clear how to perform arithmetic on numbers given with infinitely long decimals, meaning numbers that go on forever. You can't solve anything that with numbers that go on forever. So what you have to do is you either have to round them like we did last time, or if we approximate these numbers by what's called truncating. Truncating means just cutting it off, like literally stopping the number wherever we are told to stop, whatever place value. Doesn't mean round it there, doesn't mean do anything like that. It means literally just cut off every other digit behind it, and that's the number we're going to use. So looking at this example right here, it says truncating a decimal expansion to the n decimal place gives us the approximation with an error of less than that amount. So 1 over 10 to the nth power. So for example, if I'm going to use the number 0.676 for an approximation of this repeating decimal 0.676767, if I were to round it to this place, this actually would have been written as 0.677 because the fourth digit behind it here, 1, 2, 3, 4, that 7 would have bumped that 6 up to a 7. But since we are truncating, that literally means cut everything off. And that's the only three numbers you're going to use. And for our calculation, our error, or what we're going to be technically off by, is less than a thousandth. And for most things, that's acceptable. By the way, that's third grade right there. Beast mode. Not really. All right. So for the first one, part A, it says commute the decimal expansion of 5/6 and 7/9. So what that means is take it from a fraction, turn it into a decimal. And so if I do 5 divided by 6 in my calculator, I get 0.833, and that 3 repeats forever. And if I do 7 divided by 9 in my calculator, I get 0.77, and the 7 just repeats forever. So that's all I have to do for the decimal expansion of that. That's my answer there for those two. This one goes with this. This one goes with that. Part B says, what is the answer to 5/6 plus 7/9 as a fraction? So first, to add those two together, I know I can only add fractions if they have the same denominator. I do not right now, but I know the smallest number that both 6 and 9 can go into is 18. And 6 turns into 18 by times 3, so whatever I do to the bottom, I must do to the top. So 5 times 3 is 15. Now I'll deal with changing 7/9. 9 turns into 18 by times 2. Whatever I do to the bottom, I do to the top. 7 times 2 is 14. So now I'm allowed to add them because they have the same denominator. And 15 plus 14 is 29. And then the next part says, what is this decimal expansion? So when it says, what is the decimal expansion, it just means change it from a fraction to a decimal. So when you plug in 29 divided by 18 in your calculator, you would get 1.6111, and those ones repeat forever. So it is non-terminating. So I can just finish it like that. That's my answer for part B. Part C says, what's the answer to 5/6 times 7/9 as a fraction? Now, that first part, to multiply fractions, it's literally the numerator times the numerator. So 5 times 7 is 35. And then the denominator times the denominator. 6 times 9 is 54. Once I get that answer, it says, according to your calculator, what's the decimal expansion? So they are asking, what is 35 divided by 54? And when I put that in my calculator, I got 0.6481, and then 481, 1, 4, 8, 1. And this is the part that is repeating. Those three numbers will repeat forever. All right, so part D here basically asks us this. If you were given just the decimal expansions of 5, 6, and 7 ninths without knowing what fractions they came from, do you think you could easily add the two decimals to find the expansion of their sum? Or could you easily multiply them to find their product? The simple answer is no, okay? If I had those numbers that went on forever, as they do up here, I cannot easily compute addition or multiplication problems or division or subtraction, because if those numbers never end, I can't begin my problem. So what I have to do is either round them like we did last time, or do what we're doing today, truncate them. Just cut the number off and use whatever place I cut that off at to do my operations with. That's the only way it's going to work. So as we work through this, I'll have you pause and do it on your own, then work with me. But here's our first example here. So exercise 1. It says there's two irrational numbers, x and y. They have infinite decimal expansions, meaning they go on forever. And so here's the first number. I'm not going to read that all out. And that represents x. And then we've got a second number that represents y. All right. Part A says, explain why 0.670 is an approximation for x with an error of less than 1,000th. Or I could write 1,000th like this, 1 over 10 to the third power, just so you know. And explain why 0.849 is an approximation for y with less than 1,000th, 1 over 10 to the third, okay? So for that explanation, pause, think about it. All right, now that you're back in the video here, the reason why you can do that is we're doing what's called truncating. They're saying after the thousands place, just cut it off. So looking at my first number up here, I see 0.670. This 0 right there is in the thousands place. I can cut everything else off. I'm not worried about rounding it. I'm just literally cutting off every other digit. That's why it's acceptable. And for my next number, 0.84991. Well, they're saying we're truncating today, all right? We're just cutting it off. We're not rounding. If I were rounding, the 9 in the 10,000ths place would bump that 9 in the thousandths place to a 10. But we're not doing that. We're literally just cutting the number off, and we're saying we're just going to use that. That's what truncating is. So it wants you to explain. Well, that's kind of our explanation right there. We're doing what's called truncating. We're just cutting the number off there, and we're using the first 3 digits to the right of the decimal, the thousandths, and that's it. So for part B, it's asking us to use those numbers from above that we truncated to solve these questions. The first one says x plus y. So my x number is that 0.670, and we're going to add that with the y, which is 0.849. Obviously, feel free to use a calculator. I've already got this set up. 9, 11, 15, carry the 1. So 1.519 should be your answer when you add them. So this one here is done. Next, it says you want to multiply them. So here's my first answer for the adding. So for the multiplying, so go ahead and put that in your calculator. Do 0.67 times 0.849. If you need to, hit pause for a second. Now that you're back, you should have gotten 0.56883. And the reason why I'm writing that all the way out, sure, these 2 digits go past the thousandths place, but it didn't tell me to round my answers anywhere. So I'm writing the full answer, unless I'm told to round or truncate to a certain spot. If the directions do not tell you to round or to truncate, then write the full answer. So that's a good thing to remember about today. Then finally, for this third part of the equation, it says first square the x number, get an answer there, and you're going to add that answer with 7 times y squared. So this one's got multiple steps to it. So with this, I'm going to use a different color to help this stick out a little bit. When I squared 0.67 or 0.670, I got 0.4489. And then when I squared 0.849, okay, now this is a little bit longer number. It's going to be 7 times this answer. But when I squared the y, it got me 0.720801. Again, I didn't round it. I didn't cut any of that off. I wrote out the full answer. I'm going to take this, and now I multiply it by 7 because that was my next step in order of operations. When I multiplied that by 7 in my calculator, I got 5.045607. And my last step is to add that with the answer of my x squared of 0.4489, which I got from right here. So then I add those two together, and my final answer for this entire part here is 5.494507. And I know that was a little fast, but feel free to rewind and watch. But you got to do each step first. So to kind of recap, I did x squared, wrote that answer down. I did y squared, I wrote that answer down. Then I took that answer, multiplied it by 7, and I wrote it over here. And then I did the final step of adding that with this to get my final answer. Okay, part C. It says repeat part B, but use the approximations for x and y that have errors less than 1 over 10 to the 5th power. Okay, so this is why I wrote this like this, to give you an idea of what they're saying. They could give it to you one way. So they could tell you this in word form, or they can give it to you as a fraction. So they're saying they want you to cut it off after the 5th digit to the right of the decimal. So 1, 2, 3, 4, 5. After this digit, everything else gets cut off. That's what they wanted you to use. And if you go back up to the original problem, you are simply just going to use the full numbers there. Because if you count it 1, 2, 3, 4, actually, no, you're not. 1, 2, 3, 4, 5. If I cut that off, I'm cutting off the 2, 6, 7 from that one. And for this one here, 8, 4, I'm cutting everything off after the 1. Okay? So I want you to repeat part B using everything from that. Okay? So with that said, if I go ahead and do those steps, hit pause. Okay, now that you're back, I'm going to go ahead and actually create a new page and kind of work those answers out. All right, so when you added them together, you should have gotten 1.52026. That was for the adding. So that was let's call that part A. The next part, you were told to multiply the two digits together. And if you did that, you would have gotten 0.5697371685. And then that part C, where you had to square the x, and you're going to add that to the answer of 7 times y squared, you would have, your final answer there, let me check my work a little bit. There it is. You should have gotten 5.507981179. And sure, I'm giving you the answers, but honestly, you should go back and make sure you've done that work if you haven't yet, just to make sure you can do these things. So that way you fully understand what's going on there. Okay? So what I'm going to ask you to do now for this exercise 2, go ahead, hit pause, do as much as you can on your own, and then I'm going to kind of work through this quickly when you come back. Hit pause now. Okay, so I'm going to make the assumption you have done all the work, you've hit pause, you've worked on your own. Let's work together now. It says 2 real numbers. You've got an x value, you've got a y value. Those 3 dots at the end represent the fact that they go on forever. Part A asks us to do this. Use your approximations for x and y that are accurate within the measure of 1 over 10 to the 3rd power. Hopefully you recognize immediately saying cut everything off after the thousandths place. which is right here, if I can get my decimal in. Yeah, so everything after that, you just cut it off. We're not rounding it. So if I'm doing that, you should have cut off all of that and all of that. And those were the numbers you should have used. Okay, so for part 2A, you should have gotten, and I'm just giving the answers for the addition first, you should have gotten 0.460. And for the second part right here, y minus 2 times x, you should have gotten, let me make sure my work, part A, .0.001. All right, for part B, you were, now instead of going to 10 to the third, it's 1 over 10 to the 7th. Okay, so if I'm looking at that, let me see where the cutoff would be. 1, 2, 3, 4, 5, 6, 7. So it's actually using all the digits that they gave us for both of them. So there was nothing to cut off. So you were actually using all of those. So when you added those together, okay, so the first part said add them together, you should have gotten 0.4615384. And then when you did the y minus 2x, you should have gotten, here's the last part, 0.0000001. Hopefully you're kind of seeing a trend there. Part C says we now reveal that x equaled 2 over 13, so that's what the fraction representation was. Y equals 4 over 13. How accurate are your approximate values for y equals minus 2x from part A and part B? So looking at this, they're pretty close. I mean, this one is just a thousandth off, and then this is clearly, you know, a very small percentage that is off. So how far apart are they? They are very close to each other. They're very acceptable answers. Okay, so that's what that meant. That's how accurate it is. It's very accurate. Part D says, compute the first 7 decimals of 6 divided by 13. So all I do is 6 divided by 13, and I get 0.46115384. Okay, and it says how accurate is that 6 divided by 13 to the x plus y from part A and from part B. So what they're saying is compare this to this right here. And if you look at that, again, it's pretty accurate. It's pretty close. So those are pretty acceptable answers. So it shows you at some point it might just make sense to truncate a number or, like previous lessons, round them off and get an answer. Typically, we are only going to work with numbers that go to the thousandths place, but this is showing you even if you go further out, the numbers are relatively close to each other. So all I'm going to ask you to do from here is do your problem set. There was only one question. Your answer's on the next page. Do your exit ticket, which will be on Edulastic. If you get any questions, you guys have done a fantastic job of emailing me. Let me not do that yet. Let me turn that around. Here we go. So do all of those things. You guys are doing great. Keep up the great work. I'm really proud of you. That's really all I got. Email me with questions, and I will talk to you